And this is a good opportunity for me to introduce the app which goes with it.
There's got to be an answer.
There is an app called Magic of Reality, which contains all the text of the book and all the pictures by Dave McKean in the book. But it also, in every chapter, it has a simulation, a game, an animation. And I want to demonstrate one of those. Unplug it, I'm afraid, to plug in the iPad. I'm sorry, it only runs on the iPad. Isaac Newton, who more than anybody else worked out the principles of orbiting bodies, asked us to picture a cannon which would fire cannonballs at increasing velocity. And I'm going to try to do this. I placed my cannon on the top of the world in the North Pole, and there's a sort of pea shooter sticking out of the back of the cannon, which enables you to fire the cannon, and you control the velocity by pulling the pea shooter back different distances. And you can steer the up and down of the cannon as well. I'm going to try to do it, although I'm not very apt, is that the right word? That splashed into the sea. I'll get as far as a bit faster. And that went into outer space. It tried to curl round and was about to go into orbit, but didn't quite make it and went off and reached escape velocity. There we go. Yeah. And while I've got the app plugged in, I might as well demonstrate a bit more from it. You see the text and the pictures flow through. And what's that? That's another. Yes, you can have. Yes, that's showing the why they're winter and summer. But the spotlight's a bit fierce on the screen, so it's a bit harder to see. But you can tell that it's the side that's tilted towards the sun, of course. It has sun. Across the top here we have the chapters. I'll go to what is a rainbow chapter. And then here we have the various pages of the chapter concerned, beginning with the myths as usual. Yes, there's a familiar myth. That, as of course you know, comes from the Epic of Gilgamesh. A man called Utnapishtim was warned by the gods that there was a great flood coming. And the gods told Utnapishtim to build a great boat and to take 2 of every animal on board the boat to save all of life. And at the end, when the flood went down, the gods placed a rainbow in the sky to guarantee that there never would be another major flood like that again. Okay, I'm going to leave the app now and go back to it. I'm now going to skip to chapter 9, which is called Are We Alone? This is a slightly unusual chapter because it's much more speculative than the others. Most of the other chapters contain quite a lot of what we already know. Of course, it's important that in science there's a lot that we don't know. And one of the main things we don't know is whether we are alone in the universe. It's a very interesting question. Most people are fascinated by it. Carl Sagan was once asked whether he believed that there is life on other planets elsewhere in the universe? And he said, I don't know, which is the right answer. But his questioner then pressed him and said, but what is your gut feeling? And Carl Sagan immortally replied, but I try not to think with my gut. We can only guess, and our guesses don't have to be completely lacking in information. We can use science to inform our guesses by making calculations about the various things we might need to know in order to roughly estimate the likelihood that there is life elsewhere. This chapter is also unusual in that there don't seem to be any ancient myths about extraterrestrial life, probably because in ancient times the very concept of extraterrestrial wasn't around. It was thought that terrestrial was it, this was it. And there were stars going around, but nobody really thought that the stars might be extremely numerous, extremely distant, and extremely large, and might have planets of their own. So for this chapter, in my myth section, I had to turn to modern myths. About 4% of the American people seem to believe that they have personally been abducted by aliens on flying saucers, and in some cases subjected to the most undignified sexual experiments. Actually, visitation by physical bodies is enormously less likely than visitation by radio waves. If we ever do discover life elsewhere in the universe, it is highly unlikely to be actual physical bodies visiting us. It's much, much more likely to be radio transmissions, for the simple reason that radio transmissions go at the speed of light and radiate outwards in all directions, whereas physical bodies, unless they're very, very advanced, don't go anywhere near the speed of light and don't radiate out in all directions, that's for sure. So let's come to the question, is there really life on other planets? And as I said, we don't know, but we can sort of write down what we would need to know in order to make some rough calculations. And one of the things we would need to know is how many stars there are and how likely it is that they have planets. Well, the number of stars is simply prodigious. The next slide shows a simulation of a rocket, let's say, retreating away from the sun. So there's the sun, and now we're retreating away from it. And it's now invisible, it's become too small to see. And we're going further and further and further away from our home. And now we see the Milky Way galaxy. And then we see other neighboring galaxies. Now those are all galaxies, those things that we see retreating. A reasonable estimate of the number of stars in the universe is about 10 to the 22. Until recently, we didn't know whether any of those other stars had planets. It was only a sort of guess that it's unlikely that our sun would be that unusual to be the only one that had planets. It has recently become possible to detect that other stars actually do have planets, and by a rather interesting way. You can't actually see them directly, or it's very difficult to see them directly, because they're too small and they're too dim, because they only shine by reflected light from their star, rather than emitting light like the star itself. So the indirect way in which planets are detected is by the effect that they have on the movement of the star. When we say that a planet orbits its star, when we say that Jupiter, say, orbits the sun, that makes sense because we think of the sun as being in the middle and Jupiter going round and round. But actually, the larger the planet is, the more is the tendency for the two to orbit each other. And there are binary stars which are approximately the same size as each other, and they go round and round like a pair of dumbbells. Well, Jupiter's not big enough for that, but when Jupiter orbits the Sun makes small token movements, as though sort of make a little apology for an orbit of Jupiter. We can't easily see those movements either, but what astronomers can do is measure the Doppler shift in the colour spectrum of the light that's coming from the star. So when the star is moving away from us, its spectrum is shifted in the red direction, and when it's moving towards us, its spectrum is shifted in the blue direction. So if we look at the spectrum of a star, and we see that it shifts red, blue, red, blue, red, blue, with a periodicity of, say, some months, then we can infer that there is something orbiting that star with that periodicity. And it's that method that is responsible for most of what we know about extrasolar planets. And it's starting to look as though the majority of stars do have planets in orbit around them, which means that that figure I put up there is probably an underestimate for the number of planets. But of course that doesn't mean they're suitable for life. It may be that suitability for life is extremely rare. One point that's been made is life, as we know it, depends upon liquid water. And astronomers or exobiologists talk about a so-called Goldilocks zone around a star. Goldilocks zone being just right, not too hot, not too cold, but just right, like baby bear's porridge. So there I've drawn, or Dave McKean has drawn, the green Goldilocks zone, and Earth is in the Goldilocks zone for our Sun. And then there are planets that are inside the Goldilocks zone, too hot, planets that are outside the Goldilocks zone, too cold. So that's going to reduce our 10 to the 22 very substantially. It will only be a minority of planets that are in the Goldilocks zone with respect to water. And of course we don't know that extraterrestrial life depends on liquid water. It may be so alien that it depends upon something quite different, like ammonia. But if it's anything like our life, it needs to be in the Goldilocks zone for liquid water. Maybe there are other Goldilocks zones. Maybe for gravity. A planet which is extremely heavy, extremely massive, will have a very strong gravitational field, and that will put constraints on the kind of life that you can expect to find there. Dave McKean has fancifully drawn a mouse-sized animal which is built sort of a bit like a rhinoceros, with great big tree stump limbs, on a planet with very large gravitational field, and on the right, a rhinoceros-like animal on a very light planet which skitters around like a long-legged spider.